numeric, or floating point computation. Quantum Mechanics by Maple is a complete course, contains 38 videos for beginners. During this course, student will be able to use Maple step by step in quantum mechanics. The first video of this series explains mathematical expressions, the second video explains mathematical functions, and the third video explains exact quantities and numeric quantities. The fourth video of Quantum Mechanics by Maple discusses the methods for converting exact quantities to numeric quantities. The fifth video of this series discusses the types of computations, including symbolic and numeric computations. The sixth video of Quantum Mechanics by Maple discusses the first type of computation, symbolic, abstract, or exact computation. This video is the seventh video of this series and discusses the second type of computation, numeric, or floating point computation. As it expressed earlier in previous video, there are two types of computations. 1. Symbolic, or exact computation. 2. Numeric, or floating point computation. In this video we are going to explain numeric, or floating point computation. Numeric, or floating point computation is the mathematical manipulation of expressions, or functions, involving numeric, or floating point quantities. In numeric, or floating point computation, expressions, or functions, involving exact, or symbolic quantities, are replaced by close approximations using numeric, or floating point quantities. In Maple, numeric, or floating point computation is normally performed if you use floating point numbers containing a decimal point. As it expressed earlier in previous video, if Maple by symbolic, or exact computation, does not find any solutions, it is recommended that you use numeric, or floating point computation. In order to illustrate and discuss numeric, or floating point computation, let's consider the following example in Maple. Example: by using of numeric, or floating point computation, find the volume of the solid of revolution, formed by rotating the region bounded by the x-axis, and the graph of 1 plus cosine x, from x equals 0 to x equals 2, about the x-axis. The graph of this volume of the solid of revolution is In order to better understanding numeric or floating point computation of the volume of the solid of revolution, at first let's find this volume by symbolic or exact computation. By using of symbolic or exact computation for this volume, we can obtain the following amount. In order to find this volume of the solid of revolution by numeric or floating point computation, we can use, for example, disk method. By using of numeric and floating point computation for this volume and increasing the number of partitions, disks, for example, for 5 partitions, disks, we can obtain the following amounts. Again, by increasing the number of partitions, disks, for this volume, for example, for 10 partitions, disks, we can obtain the following amounts. Again, by increasing the number of partitions, disks, for this volume, for example, for 20 partitions, disks, we can obtain the following amounts. Again, by increasing the number of partitions, disks, for this volume. For example, for 40 partitions, disks, we can obtain the following amounts. Again, by increasing the number of partitions, disks, for this volume. For example, for 60 partitions, disks, we can obtain the following amounts. Again, by increasing the number of partitions, disks, for this volume. For example, for 80 partitions, disks, we can obtain the following amounts. As we can see, when the number of partitions, disks, are increasing, the results of numeric computation approach to the result of symbolic computation. Finally, if there are sufficient number of partitions, disks, then the results of numeric and symbolic computations are the same. Numeric computation gives us approximate solution, but symbolic computation gives us exact solution. So if there is a possibility to get the solution by symbolic computation and numeric computation, then we prefer the symbolic computation. An important question arises when you compare symbolic computation and numeric computation. What is the advantage of numeric computation over symbolic computation? In other words, why do we use numeric computation over symbolic computation? As an answer to the question, we should emphasize that some problems are difficult to solve by symbolic or exact computation. When symbolic or exact computation is impossible to solve complex problems and fails to find the solution, in such cases, numeric computation works very well. Symbolic or exact computation has limitations in case of nonlinear problems. In such cases, we can use numeric computation. Numerical methods can solve real problems which exist in reality, but symbolic methods can solve ideal problems which in many cases do not exist in reality. It is worth mentioning again that, if Maple by symbolic or exact computation does not find any solutions, it is recommended to use numeric or floating point computation. In the next video, we will discuss more about numeric or floating point computation.